So welcome everybody to this latest video on 162 Math, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on all things related to graphs at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now, before we get started working through this test, it's worth mentioning that there is no indication about whether these questions are specific to a calculator or a non-calculator paper. So what we'll do is we'll just assume that they're non-calculator just to anticipate worst case scenario. So let's move on to question one. So question one, all it's asking us to do is to plot the points -2, -1 and 1, 1, labeling the coordinates A and B respectively. So here we've got -2, -1, which is going to be here. I can label that as A, and B is at 1, 1, which is there. Then it says that ABCD is a square. Write down the possible coordinates for C and D. And so what we need to do is just imagine that this is a side of a square. So looking at this, our coordinates could either be, and looking at this, you can see that the distance from A to B is 3 across and 2 up. So if I go 2 across, 3 down, so it could be here or it could be there. So this could be C and this could be D. So let's just label that as C1, D1. Or you could find that the coordinates are going in the opposite direction. So this could be C and this could be D. Well, actually, that's going to be D. And let me just make sure I've got those coordinates right. So flip that around. So this could be C. And the reason why I'm just relabeling these, because you tend to find A, B, C, D tend to go in sort of from points to points. Otherwise, it'll look like a egg timer. So then here, this is actually going to be D1. And this point here, 3, 2, is going to be C2. So I could write any of those two coordinates. So for this, we're looking at C1 being at, and that is at 3, -2. And D1 is at 0, -4. Or you could have the coordinates of -1, 4. Oh, don't know why I've put a D there. And so C2 could be -1, 4, and D2 being -4, 2. So any of those two possible answers would be absolutely fine. Now, again, they've not labeled the C and D, so if you were to write the coordinates the other way around, that should be okay, but just make sure that you are looking out for those particular things. Moving on to question 2, it says complete the table for y equals -4, -3x. Now from this, you should be able to spot or know that this is going to be a straight line graph, which basically means that when the x ordinates are going down in sort of the same sort of steps, that the y ordinates should follow a similar pattern. So because it's a straight line, you can see here that I'm taking away 3 between each of the numbers, which therefore means then to work out this number, all I need to do is -1, take away 3, which gives me -4. An alternative you could do is obviously just substitute x equals 0 into this particular formula. So I'm going to end up with -4 -3 times 0. Well, that's going to be 0. So it's just going to be -4. So several ways in which you can do this. Now for the next one, it then says to plot the coordinates that you've then found. So the first one is -2, 2, which is here. Then it's at -1, 1, which is going to be -1 rather, and that's going to be a little bit more awkward to plot, but that's going to be there. Then at 0 it's at -4, at 1 it's at -7, which is about there, and at 2 it's at -10. And then what you then need to do is with a ruler is join those points up. Now again, this is going to be incredibly awkward me to do. Now you do need to make sure that you do go through each of the lines, and I would say always try and extend your line where possible, but the question is asking from -2 to 2, so let me just make sure that that is accurate as I can make it. which is about there. And you can see that all the line goes through all the points that I've just plotted. Moving on to question 3, it says circle the y-intercept of y minus 2x equals 3. So it's not looking at the above line, it's looking at this another separate line. So for this, what I need to do is to make it into a y equals mx plus c. So I need to take this 2x over to the other side. So I get y equals 2x plus 3, or 3 plus 2x. Now the y-intercept is always the number that's being added or subtracted, which is positive 3. So the correct answer is our last option. Moving on to question 4, it says circle the equation of the line that is parallel to y equals 6 minus 3x. So here my gradient is minus 3 and parallel lines have the same gradient. So here for this first option, my gradient is 3. For this second one, my gradient is minus 3, and that is the same. So I don't need to worry about the other two because it's only one that I need to circle. For the next one, it says which of these is a sketch of 5 minus 4x. So for this, I'm looking for a y-intercept of 5. I've got a negative gradient, so the line needs to be going downwards. So I'm looking for a y-intercept of 5 and the line going down. And the only possible option that's going to be is going to be B. Moving on to question 6, it says A is at 3, 8 and B is at 7, 0. Work out the gradient of the line AB. So for this, what I need to do is turn this into a triangle and also need to note the points. Now A is at 3, 8, so this is going to be 3 and this point here is going to be 8. And B is at 7, 0, so this is at 7 and this is at 0. Now to work out the gradient of a line, what I need to do is to work out the height and the base of the right angle triangle. So here the difference between 8 and 0 is 8 and the difference between 3 and 7 is 4. So here the gradient then is going to be 8 over 4. Now with this, it's a line going downwards, so it's going to be a negative gradient. So therefore then the answer is going to be minus 2. Then moving on to question 6, it says CD is a line that is parallel to AB and passes through 0, 5. Work out the equation of the line CD. Now for this, what we notice is that the y-intercept, which is a mark to C, is going to be at 5 and plus 5 at that. So here I'm looking for a gradient of minus 2 and a C value of 5. Or plus 5. So then using y equals mx plus c, I'm going to end up with an equation of y equals minus 2x plus 5. Then moving on to question 7, it says that A is at minus 5 minus 2 and B is at 2 minus 3, C is at 4, 1 and D is at minus 3, 2. And it says A and B and D and C are parallel. Work out the gradient of A and D. So for this, what we need to do is look at the points. So for this, let's just mark. So this is the line that I'm wanting to work out the gradient of. So at A, if I turn that into a right angle triangle, like so, we know it's got to have positive gradient. So D is at minus 3, 2. So this is at 2 and this is at minus 3. And A is at minus 5 and at minus 2. So looking at that, we can see that the height of that triangle is 4. And the base of that triangle is the difference between minus 5 and minus 3, which is 2. And we've got positive gradient, so it's going to be a plus. So therefore, our gradient is going to be positive 2 or just 2. It then says work out the gradient of BC. So again, if I do exactly the same, so if I draw a line, and then turn that into a triangle. Now here, looking at the coordinates of C, so this is at 4 and B is at 2. So I'm looking there at the X ordinates. Then if I look at the Y ordinates of C and B, I've got minus 3 and I've got 1. So here I'm going to have a height of 4 and a base of 2. So here it's going to be 4 divided by 2, which is positive 2 again. It then says what type of quadrilateral is AB and CD? Well, because we've got two sets of parallel lines and there's no 90-degree angle, it's therefore going to be a parallelogram. And the reason for that is because we have two sets. So as we have, and let me just write that properly. So here, as we have two sets of parallel lines. Oh, don't know why I've put that little extra little C there, so let's get rid. And no perpendicular lines. The shape A, B, C, D is a parallelogram.